Live off the popular game Fruit Ninja because we were working with fruits and knives. So our original plan was to bounce a ping pong ball and then do different things with the paddle and use video analysis to figure out different things. But after we did the warm up, talking about the knife in the foot, we decided to change our lab to critical pressures.
Our purpose, we want to determine the critical. We did a little research, and we realized that when you want to split a fruit, that pressure is called critical Turgor pressure. So we want to determine the critical Turgor pressure of 4 different fruits, and then try to find the equivalent pressure of a Nerf football, foam football. So we plan to do this by dropping a knife into the objects from various heights, 3 different heights. And then by using all the data that we gathered, calculate the pressure applied by the object in order to stop the knife. So, you want to show the diagram now? Let's see what's next. Okay, so these are the objects we tested. Tested 4 fruits. That's a squash and a pumpkin, and an orange and banana, and then a foam football. And this was the order of. We thought that the squash would have what, the highest pressure?
Yeah.
So it would take a greater force to penetrate it. So this was the order. This is what we hypothesized. So what do we have to do? Click applied vision. Click that applied vision thing.
So yeah, the Turgor pressure we found was caused in fruits by the water in the cells or something. We figured it'd probably be similar for the foot, but not for the football, obviously.
So what do we press record? Or?
Oh no, it's going to show you whatever you set down there.
Oh. Okay, so this was, I gotta get it. So this was our apparatus right here. We used Mitchell's Porch, and with a meter stick, we measured 3 meters to the top of the tube, and then we duct taped it. So this was going to be like where we dropped the knife through, and then way down below was going to be our cutting board with all the fruits on it. And then this is a picture of a squash with a knife in it right here. And then this is the cutting board down below. This is an orange that was massacred.
Okay, so yes, we decided to use the tube because when we were first trying it, the knife wasn't falling straight and it wasn't going in to the objects, so yeah, we were talking about that. We did 10 drops from each height. Well, that's what we got data for, but it took so many drops because they kept bouncing off or we didn't have it lined up right. So that was probably the hardest part. And then for some of the fruit, like the orange and banana, we obviously couldn't do 3 meters, so we just had it, like, we had a smaller piece of tube and dropped it from lower heights. The duct tape was used to hold the things in place. And then, so we measured how far the knife went in to the object, and then we also measured the area that the knife caused, like the puncture. And then from there, we'll show you later how we calculated everything else. Yeah, here.
So this is just one data table for the squash. So we took the mass of the knife, and we probably could have used a motion sensor to calculate the speed of the knife, but I don't know, it's kind of, I guess, a little dangerous. I don't know. We didn't really think about how we could set it up to make it work. So we asked Dr. Schuster, and he said we could use like Miasmi F's, so V equals root 2GH. So this is the velocity of the knife from these heights, and then this is the depth that the knives penetrated into the object we measured, and then we calculated time by rearranging equation. What was it? Depth multiply by.
Yeah, so that time is the time it took for the object to stop the knife. So we used.
It's not from the drop, it's from when the object entered the
and
object
stopped.
and then stopped. So it's that small time that it accelerated, decelerated, from its greatest speed to 0. And then we use this to find acceleration, or the deceleration, and then multiply that by the mass of the knife to find the force. Then we measure the area of the incision, and so then we could, using the average force and the average area, we could find pressure. So this was a graph of the critical pressure of the squash, and we were correct in saying that it was the highest critical Turgor pressure out of all of our fruits.
This is what happened when we tried to do the foam football. So, kind of disaster, I guess. We didn't really know what to do with this, so we didn't do anything with it. So we figured our errors were, sometimes we would drop it in and it would barely go in if we dropped it too close to the stem or something. So we threw out some of that data, and then also, even though we used the tube, the knife was still going in it sometimes at different angles. And then we thought that the tube might have slowed down a little bit if it was bumping against the sides a lot. And then with the area, there was a better way to measure the area than we did, because we tried with the fruit. It was easy to pull it out and then sit there and measure it. But with the football, it would close back up and stuff, so we had troubles there. There were no accepted values online. There was one grape experiment, but we tried to do grapes and we destroyed all of our grapes, so we couldn't do that. And that's it.
Thank you, gentlemen.